In this problem, we need to find an explicit formula for each sequence. And the sequence is of the form a sub 1, a sub 2, a sub 3. So what this tells me is each time we're starting with n equals 1. So to find an explicit formula, the first step that I'm going to do is I'm going to make a relationship between our variable n, which starts at 1, so 1, 2, 3, 4, and so on, and the terms of the sequence, which in this case are -1, 1, -1, 1, and so on. So you can see that the pattern is just that we have 1 and the sign is alternating between negative and positive. So in this type of case, what we're going to do is we're going to say that a sub n is equal to, and then we're going to take a -1 and raise it to a power. And now the question is, what should the power be? So since we have odd numbers mapping to a negative value of 1 and even numbers mapping to a positive value, then what I can do is just make the exponent equal to n. So you can check to see that this works. A sub 1 equals -1 to the 1 power, and that gives me a -1. A sub 2 is -1 squared, which gives me a +1. And as you keep plugging in numbers, you would see that you keep getting -1, +1, alternating, whether the variable that we're plugging in for is, or the value that we're plugging in is odd or even. And so that's my formula for this problem, for number 6. Let's take a look at number 7. Now in this problem we have 0, 1, -2, 3, -4, 5. So again, I'm going to make a relationship between the variable n, which is 1, 2, 3, 4, 5, 6, and then the terms of the sequence 0, 1, -2, 3, -4, and 5. So I can see this relationship, and I see that we do have some alternating of signs, and you might think, well, 0 doesn't have a negative on it, but it's 0. So if it was a negative times -1 times 0, then we would have 0 anyway, so that doesn't matter. So for the odd terms, we get negatives, just as we did in the last problem. So when I write my solution, I'm going to say a sub n equals, and I'm going to take -1 and raise it to the n power again, because the odd numbers are associated with negatives and the even numbers are associated with positives. All right. But now that's not all there is to it, because now we're going to multiply this -1 times something. And what is the number value that we get in the problem? So we have 0, 1, 2, 3, 4, and 5, and those associate with 1, 2, 3, 4, 5, and 6. So the number value is always 1 less than whatever n is, so we're going to multiply by n minus 1. You can check to see that this works. So a sub 1 would equal -1 to the 1 power times 1 minus 1, and since this part becomes 0, the whole thing is 0. Let's try a sub 2. We have -1 squared times 2 minus 1, and that gives us a +1 times 1, which gives us 1, and that's what we're supposed to get. And you can keep checking. You really should check all of them, just to be certain. But as long as you make sure that it works for some value other than 0 and 1, because sometimes it's easy to get those to come out. But in this case, we've got 3 that we're plugging in, and we get -1 to the 3rd is -1, times 3 minus 1 is 2, and this gives us a negative 2. So we can see that does seem to be working. You can try and check the rest of them, but this is our formula. Let's take a look at number 8. In this problem, our terms are fractions. So when I set up my relationship, I have 1 going to 1/4, 2 going to 2/9, and so on. When I'm working with fractions, I'm going to think of the numerator and denominator as two separate things. So I can come up with a formula for the numerator and then a formula for the denominator, and I just make a fraction out of those two formulas. So let's try to analyze what's going on here. I've got 1/4, then 2/9, 3/16, and so on. So it seems that the numerator is whatever the value is originally. So that's just going to be 1 in this case, over, and then for the 2/9 it'll be 2 over something, 3/16 is 3 over, whatever. So we've got our numerator is just whatever the number is. Now how about the denominator? Here we've got 4 and then 9, 16, 25. I notice that these are all perfect squares. So that's 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and 7 squared. All right. So I'm not necessarily seeing what relationship that has to n immediately, but then I look and see, well, so the 2 in the denominator here, well, that's 1 more than the numerator, and then 3 is 1 more than its numerator up here, 4, 1 more than the numerator, and so on. So I could write this as 1 over 1 plus 1 quantity squared, and then I have 2 over 2 plus 1 quantity squared, and continue 3 over 3 plus 1 quantity squared. And now I think you can see the pattern to this. And that's what we're looking for here, is what is the pattern? So yeah, 5 over 5 plus 1 squared, and 6 over 6 plus 1 squared. And so what this tells me then is my formula for a sub n is n in the numerator over n plus 1 quantity squared. And I've really already checked this by checking what where I got the numbers from. So here we go. That's the final answer for that one. Let's take a look at number 10. In this problem, I see that my terms are 1/3, 4/9, and so on. And I've set up my correspondence, 1 mapping to 1/3, and so on. So let's take a look at the numerators. I've got 1, 4, 9, 16, 25, and 36. And those are all perfect squares of the number that we're starting with. So I'm going to write my formula as a sub n equals n squared in the numerator. I'm not going to write it out in as much detail as I did in the last problem. It depends on whether you're struggling with it. You can, develop your formula that way, or maybe you're just going to take a chance, write something down. You can always correct it later if it doesn't seem quite right. Now the denominators are 3, 9, 27, 81, 243, and 729. Those are all powers of 3. You might notice that with the 3, 9, and 27, and maybe even the 81, and then you can test your theory by finding 3 to the 5th power, and it does turn out to be 243, and 3 to the 6th power is 729. So we have 3 to the power of n in the denominator. And again, you can check your terms, and it turns out that that is the correct formula. So a lot of this is just practice and seeing what the pattern is, and seeing similar problems over and over again is always helpful in solving this type of problem.